Hello, in this video we'll be going through question number 26 from 2020 HSC Standard Maths exam. This is one of the tricky questions and I would strongly suggest to go through the chapter of critical path analysis for this, and especially 19.2 critical path, where I explain how to approach these questions. And most important thing is this activity chart that you really need to understand, even though the exam solutions do not teach you this way, but I feel this is the easiest way of solving these questions. I will take you through how to work this out, but just letting you know that things are there, and we're explaining each of the things that are part of this activity chart here, along with a worked example on how to do scans, forward and backward scan. And just before starting, in this box, I think I'll just give you a quick explanation. You have an activity name inside, then this is the earliest start time, earliest finish time, weight, float, latest start time, and latest finish time. How all this work, I'll explain with the exam question. So let's go back to the exam question. You're given this diagram, network diagram, and then you ask what is the minimum time needed to prepare the meal. So asking for the minimum time, we need to put that through an activity chart, and then we can determine what that minimum time is. So take this question out. What I have done is put down the question up there, and I've put made the diagram myself. So basically translated this diagram like this into the boxes, and I'll fill these boxes in front of you. Say if this is the starting point, it goes A, B, and C come from the start point, so that's how these A, B, and C are there. D is dependent on B and C, so that's why B and C depend on D depends on them. F is dependent on A and E, so E and A are connecting with F. D connects with E and G, so that's how it's here. Then you have got from F goes J and H. Then this I is dependent on G and H, so G and H, so I is dependent on that. And then J and I go all the way to the finish line. Okay, that's how it's made. The shape itself doesn't matter how you make it, as long as you've made these connections correctly. That's pretty good then. Now let's start from completing this diagram. The way I would start is you would put basically the weights, the time that each activity takes to complete. So start putting them over here in this block. That's what this block is for. So A takes 14, so you've got 14 here. B is 6, C is 8, D is 12, E is 6, F is 10, G is 9, H is 8, I is 2, and J is 7. Okay. This block is called earliest starting time, right? So that's the earliest you can start. Because these activities are initial activities, they cannot start before 0. So from the starting activities are always 0. So all these three would get a 0 here. This is the earliest finish time. So you add on the earliest start time, you add how long the activity takes, and that will give you the earliest finish time. So 0 plus 14 is 14. 0 plus 6 is 6. 0 plus 8 is 8. Now for this activity D, which is dependent on on C and B, and both of them are basically, this one would finish by 6 and this one would finish by 8. So you would always take a maximum of the two, because D cannot finish, it's dependent on both of them. So it can't start even if B is finished by 6. C is not finished, so D cannot start. So earliest D can start is the maximum of the two. So we'll put 8 over here. So again, same process, 8 plus 12 is 20, right? In this case, it's both are dependent on D, so we can take 20 from here and put 20 here, 20 here. So same process, 20 plus 6 is 26, 20 plus 9 is 29. Now similar to D, F depends on E and A. So we're going to take the maximum of this 14 and 26. So we'll take 26 here because even if A is finished, you can't start F until E is finished. So you got 26 here. So 26 plus 10 is 36. H and J both will start at 36. 36. 36 plus 7 is 43. And 36 plus 8 is 44. Okay. Again, I depends on H and G. We'll take the maximum of 44 and 29. So 44 will come here. So you've got 44. 44 plus 2 is 46. Finish time would be the maximum of these two, 43 and 46. So it will be 46. So here nothing happens, so it's 46. So you've got 46 here. So this pretty much answers what is question part A is asking. So you've got 46 here. But since you're on it, we're just going to finish the whole thing, and then answering the other parts would become very easy as well. Now, this block, these blocks are called latest finish time and latest start time. Now what we are doing is a backward scan. This block is called a float, and it's just the difference between these two. So let's do a backward scan. In backward scan, we'll take the value, what is over here. So 46 and 46. And we subtract the activity from here to get the latest start time. So latest start time is 44. 46 minus 2 is 44. And this block would be the difference between these two. 44 minus 44 is 0. So basically, your earliest start time and latest start time are the same. So you cannot, you don't have any time to lag. You have to start at 44, and the latest you can start also is at 44. So there's no lag time similarly over here. But when it comes to here, so subtract 46 minus 7, that would be 39, right? So here, if you subtract these two, you would get 3. So there is a bit of time of a lag. That lag is called flow. So what it's saying is that activity J, earliest you can start is at 36, but the latest you start is 39. Even if you start by 39, it's not gonna make a difference overall at the end of the process, because if you start at 39, you'll finish it at 46. 39 plus 7, it takes time of 7 minutes or 7 hours to finish this, so you'll finish it by 46. And then in any case, I is gonna finish at 46, so you would be ready by the time I finish. So that's why you're not gonna make the process go, not gonna cause any delay to the process. Okay, so we continue this backward again. 44, we take it here, and 44, this depends on this as well, we take it over here. Again, 44 minus 8 is 36. So again, there is no lag between. 36 minus 36 is 0. Whereas here, if you do, let's do here, 44 minus 9 is 35. So here there is a lag of 15. 35 minus 20 is 15. Okay, 44 minus 9 is 35. Now in this situation where there are two, in forward scan, in these kind of situations when there are two of the nodes are coming back, you take the maximum. In this case, in backward scan, you take the minimum value. So here you can take 39 or 36, but because 36 is minimum, so you take 36 over here. So then again, 36 minus 10 is 26. 26 minus 26 is 0. Okay. Then bringing that back, 26 over here, and F is connected to A as well. We bring 26 here. 26 minus 6, 20. 20 minus 20, 0. Okay. Now again, in this case, either you can choose 35 or 20, but because 20 is smaller, we're going to take 20 over here. 20 minus 12 is 8. 8 minus 8 is 0. Now this 8 will connect to both of them. 8. 8 minus 6 is 2. 2 minus 0 is 2. 8 minus 8 is 0, and 0 minus 0 is 0. Finally completing this, 26 minus 14 is 12. 12 minus 0 is 12. Okay, now you've completed this diagram. Now what this does is it helps you to make up the critical path. Critical path is the one where this float is 0. So those activities that if you delay it any further, the whole process will be delayed. So these are the critical activities. In this case, look for the activities that have 0 in the float. In this case, there is C, or let's write it here, C, then there is D, then there is E, G is not, F, and then H and I. So that would be the answer for part B. For part C, complete the table below showing the earliest time and the float time. We have already done it over here. This block is the earliest time, this is the float time. Okay, so earliest time for activity A is 0 and float time is 12. Now for activity G, earliest time is 20 and float time is this one, which is 15. So once you make this diagram and you understand this process, the whole way of solving this kind of questions become very easy. So very critical you understand this activity chart and each of the things in these boxes.